Hi everyone, welcome. This is Monday the 9th or Tuesday the 10th. This lesson, and you should have done for homework as of yesterday or the day before, the photochemical smog investigation. Um, and so that was an article that you had to read to answer some questions about photochemical smog. Now, so the check-in was, how did you feel this weekend? We talked about the election a little bit. So today, what I'm going to roll through with y'all is we did a quick do now, but we're going to review the two major secondary air pollutants that we went over, and then we'll talk about our assessment, our LT2 assessment. So, so for my do now, I tried to review acid rain. I asked why acid rain is harmful to the environment, and then to describe the ways. So because we're not doing Pear Deck, so an acid rain has an effect on vegetation, and so the vegetation in that when acid, because remember, acid is a measure of the concentration of hydrogen ions, and when acid falls into topsoil, it actually leaches nutrients out of the soil. And so this acid rain actually removes nutrients from the soil, which of course leaves trees, and it impacts their growth and development. And so then you have these leaves that become gray or kind of brown as a result, and the plants begin to slowly die. And so you can see as acid hits the soil, these big nutrients like calcium, potassium, magnesium, nitrogen, they all start leaving the soil, and so there's less of the nutrients for the plant itself to take up. Now, on the other hand, there's also an effect on wildlife. And so particularly in marine, like in aquatic environments, so freshwater or marine, you see here that depending on how acidic the water is this effect. And so basically, to summarize this table that y'all investigated in your acid rain clues, you would have seen that it's basically a food chain effects that starts from the bottom. And so as water becomes more acidic, it's going to affect like the bottom feeders and the insects and the kind of like the algae first. And as it affects the bottom level of the food chain, of course, the effect kind of triples upward. And so the decomposers in the bottom of the food web die first, which then have a trickle up effect, right? And so that's the effect on wildlife. So we've just summarized acid rain, which is a really important secondary pollutant for us to know. The other one is the photochemical smog, which y'all had a chance to read about for your homework. So as we get into it more, we're going to be doing assessment number 2, in which case you'll be demonstrating to me your knowledge on the impact of air pollution. All right. So I asked 2 questions about photochemical smog. The first one is, what is the difference between good ozone and ground level ozone? And so I put a picture here to remind people. And what are the 2 air pollutants that create ground level ozone? All right. So the answer to that, hopefully y'all have an idea of what the answer is, but the answers are, so photochemical smog is the bad ozone here that occurs in the troposphere down here. So there's 6 different parts of the atmosphere, because the atmosphere is really, really massive. But the 2 that I really want us to know are the troposphere, which exists down where we live, and then above it is the stratosphere here. And so in the troposphere, when ozone forms in the troposphere, it's not good. And so it's also called photochemical smog, and it exists as a pollutant that's bad for the environment, for us, for everyone. However, the good ozone exists up in the stratosphere, and it's good because it's a protective layer that protects us from the UV lights from the sun. So it kind of shields us from having the full effect of UV lights. So that's the good ozone. So when photochemical smog forms, it looks kind of like this. And we've seen it in the Bay Area oftentimes. It's kind of like this like brownish cloud that rolls in, or it's kind of this heavy looking fog that we know isn't quite fog. And that's photochemical smog, right? And so it's what it is it's a secondary pollutant, which means that it is formed first. What's released in the atmosphere is these nitrous oxides, so NO, NO2, and then also volatile organic chemicals are also released in the air, which we talked about in the article. So these are like CO2, other types of carbon air pollutants, carbon monoxide. They get into the atmosphere as this form. And then, of course, just like always, the sun breaks the bonds that bond together nitrous oxide and whatnot, and then they recombine in the atmosphere and form secondary pollutants like ozone. So the primary pollutants, it's the recombination, it's the breaking apart and recombination of primary pollutants that leads to these secondary pollutants. All right. And so what's, of course, it's, as a reminder, it's nitrous oxides and volatile organic compounds, not chemicals, compounds, VOCs. And they cause respiratory issues like asthma and lung infections. So ozone is definitely not good for us to be breathing in. And then it also blocks visibility. So you can't quite see as far. As you can kind of see in this picture, you can't see as far when it is more, there's more smog in the air. All right. So that's a brief summary of photochemical smog. Okay, so on the assessment, I will be wanting you to demonstrate what you know, what we've learned about air pollution through a short answer section and then a CER. So your assessment is 2 questions. And so the first question is going to be a short answer. And so in your short answer, you'll be demonstrating a couple of things that we've learned during your LT2 section, which is atmospheric science. For question 2, you're going to be writing your claim, evidence, or reasoning. So essentially, you're going to be writing like another paragraph. And what I want to specify about this CER and how it's different from last CER is that your evidence does not need to be a quote. It can just be concepts from anything we learned in class. All right. So hopefully that is the CER is a little bit easier to do and less time consuming because of that. All right. So before we get into the actual assessment, I want to point out a couple of things that trip people up during the first CER. So I'm going to give one example about the claim and one example about the reasoning. All right. So, okay, so let's focus on claim first. So for a claim, we have, remember this is the rubric that we always use, or that we used last time on the assessment, which we'll always use. But make sure your claim completely answers the question, scientifically accurate, is specific, that one's important, and then a complete sentence. Okay, so all right, with that in mind, let's get into the claim. So the question is, how is acid rain damaging to the environment? Okay, so I'm going to give an example of a student answer. So student answer is, acid rain is damaging to the environment because it is harmful. So then I asked the class, what is this claim lacking and how can it be improved? So your classmates answered gave a lot of really good ideas and pointed out a lot of things that the student could improve on. And so in summary, basically a lot of people were like, this claim needs to be more specific. Just saying that acid rain is damaging to the environment because it is harmful is not only kind of redundant, like repeating itself, but it's also not very specific. So I wrote a claim that I think is like A+ material claim. It says, acid rain is damaging to the environment because it prevents plants from developing and harms aquatic ecosystems. oops, I forgot from. So it's basically pointing out acid rain is damaging to the plants, and then it also is damaging to aquatic ecosystems, all right, meaning things that live in the water. So I think this is a much more specific and much more dope answer. All right. Now, let's move on to reasoning. So reasoning, remember your reasoning is like the glue that holds together evidence and your claim. And so your reasoning is like explaining your evidence so that it backs up your claim. To do that, you have to explain the science, right? In your claim, or sorry, in your reasoning, you have to explain how the evidence supports the claim, of course. You need to provide like a deeper analysis, and that deeper analysis often goes hand in hand with explaining a scientific principle. And then of course you want to make sure it's concise and clear. So you're not like repeating yourself too much, you're not, yeah, all of those things. So we're going to use the same question, how is acid rain damaging the environment? We're going to use the same claim that we just modeled, as acid rain is damaging to the environment because it prevents plants from developing and harms aquatic ecosystems. Now, I'm just going to make up an evidence. The evidence is that increased acid rain causes plant leaves to turn brown or gray and begin to die. All right, so that's a piece of evidence that we learned in class. Now, the answer, I'm going to say an example answer a student wrote is reasoning number 1 is acid rain caused plants to die, which is harmful to the environment, and especially when the leaves turn brown or gray. So I asked the class, what is this reasoning lacking and how can it be improved to meet this A criteria? And so your classmates gave a bunch of really dope answers, of course. They said that the reasoning lacked a deeper analysis, which I totally agree with. There's not, it's kind of just repeating the evidence. And then another thing is it didn't really explain the science behind why the plant leaves turn brown. So I think, so I wrote a reasoning that's even better. So it says, acid rain is damaging to plants because increased hydrogen ions in the soil removes nutrients from the soil that plants need to grow, and without the nutrients, plants' leaves begin to brown and gray. Therefore, without these nutrients, the plants eventually die, which is harmful for the environment. So in this highlighted yellow section, I'm pointing out that I am explaining the scientific principle. And by doing that, I am also simultaneously providing a deeper analysis of this evidence. I'm explaining more, I'm extrapolating more, and analyzing more. Now in the green, I've highlighted that I spent an entire sentence connecting the evidence back to the claim. So that's also a really important piece. All right. Oh, and of course it's concise and clear. I don't repeat myself very often. I say what I need to say and not much more. All right. Okay, so I wanted people to work on, I wanted people to work on the assessment. So I gave people about 20 minutes of class to work on the assessment, and they did so in the Discord voice channel. So your goal is to demonstrate your knowledge of atmospheric science with the help of your peers. So I really, really encourage y'all to like work together on these assessments, because I think that you learn more and also you catch your mistakes better when you work with people. So hopefully you guys can continue to do so. So it's in Google Classroom. That's where the assessment is. So if you go to classwork and open up LT2 Assessment number 2, that's where it is. So I'll navigate there on my page real quick. So you'll see, so on the whatever period you're in, go to your APES, and then it's the first one on the top under Unit 1, Non-Renewable Energy Resources. So I'm opening it up. So it's long, but it's because it's full of instructions. So in the directions, it says to use this resource box to look up anything you might need to know. And so of course I have the lecture slides from class. I have the air pollutants dictionary that y'all co-created in class one day. I have the acid rain investigation that y'all also worked together in class last class, as well as the photochemical smog investigation y'all did for homework last class. So all of these are available to you right here via links. You can also click on question 1 and question 2, and it'll navigate you to the different questions. All right. So in question 1, remember I said that there's a short answer question. And so basically I want you to look at this graph, look at the details on it, really examine this graph, and then try to answer the questions following it about what it means that national park visibility has changed over time. Visibility meaning how far you can see. Okay, and so what air pollutants responsible for that, blah, blah, blah. Okay, so then you have the short answer portion. So the short answer, oh, sorry, not the short answer. So this is the rubric for the short answer. I want you to be able to demonstrate these within the 4 questions that you'll answer. All right. Okay, so for question 2 is a CER. So this CER, it says, imagine if the 2022 midterm elections, there's a proposition on the ballot, a new law you could vote to pass or not pass that stated California will further limit the amount of nitrous oxides and sulfur dioxide released in the atmosphere from fossil fuel burning by 2030. And so you'll use the CR format to compose an argument about whether you are for or against this proposition. So again, just a reminder that your evidence, it doesn't need to come from a quote. It can be a summary of a fact that we learned in class. And then as long as you use your reasoning to really explain it and have it support your claim. So your CER is your argument. You can pretend like you're trying to explain to your older brother or your auntie or your mom about why they should vote for this proposition, or why not. But hopefully it's why you want to vote for this proposition. So of course the expectations and the rubric for the claim is down here. And that is it. So you have, oh, here's a cute panda picture. So you have until Wednesday the 11th, so you have 2-ish days at midnight to finish this. And then a reminder, this is a reminder to please sign up for the AP College Board. It is a formality. It does not mean that you actually have to take the AP exam, but it just helps out me in Ojai. So those are the join codes, and that is it. Please hit me up if you have questions about the assessment. Please, please, please do it. And I'm happy to help you if you need it.